starting again.
All right, we're going to do problem number 1 from page 5 of the homework packet. This one, I'll read the problem just to make sure you're doing the same one as I am. It says, at a particular temperature, KEQ is equal to 4.2 for the following reaction. 2HBr makes H2 plus Br2. What we're going to do is we're going to see if we can find the concentration of Br2 at equilibrium. We know the initial concentration of HBr. So I'm going to use my Rice table, and we're going to plug in our numbers and work through this problem. The reaction, that's my R line, is 2 HBr makes H2 and Br2. My initial conditions, if you read the problem, it says that you've got 0.2 moles in 1 liter. So by definition, 0.2 moles in 1 liter is a 0.2 molar solution. We can assume that there's no hydrogen and no bromine present. The change line, right? So if we think about it, we've got to lose from the reactant side, and we're going to gain on the product side. How much are we going to lose? We don't know exactly, but we do know we're going to lose X amount, and we're actually going to call it 2X because the coefficient in front of HBr is 2. And we're going to gain on the product side. We're going to gain X amount. We're going to gain X amount of the Br2. The equilibrium. Now, this problem is a little different because I don't know any one of those substances' equilibrium concentrations. So the best I can do is to say, well, it's going to be 0.2 minus 2x. I also know over here it's going to be 0 plus x, so we can just call that x. Same on the bromine, 0 plus x. These are going to be my equilibrium concentrations. This problem, we do know KEQ. So if I go back to my KEQ equation, so KEQ is equal to concentration of the products over concentration of the reactants. Right? So I've got my KEQ expression. I know the value of KEQ, and I also have variables that I can plug in for each of these terms. So let's do that and see what it looks like. KEQ is equal to 4.2, and that was given in the problem. We've got H2 is X times Br2 is X. And the HBr is 0.2 minus 2x. Make sure you square it, right? We had to square it in the KEQ expression. So really all I've done is a simple substitution, right? So I've got this equation. Now, this is really just an algebra problem, right? I can take and solve for x. If you can do that algebra, then we can find out what x is. We can plug it back in to determine those equilibrium concentrations. Let me just simplify this just a little bit. I'm going to rewrite it. Instead of x times x, I can just write x squared, right? And since you have a square in the numerator and you have a square in the denominator, I can take the square root of both sides of this equation and simplify it that way. If I take the square root of 4.2, let me just crank that out on my calculator real quick. Yep, that was 2.05. Is that the same answer you got? Good. Equals x over 0.2 minus 2x, right? I'm going to get rid of some of this math up top just to simplify things a little bit for us. I'm actually going to go ahead and rewrite that equation because I'm going to work my way through the math. So we said 2.05 equals x over 0.2 minus 2x, right? So once you get here, again, like I said, this is really just an algebra problem. So pretend like you're in math class and solve it. I'm going to multiply, get x out of the denominator. Don't forget to distribute. Okay. Again, I'm going to crank out and get my calculator rolling. Right. We better make sure that we each get the right answer. I got So I got 0.41 minus 4.1x equals x. We're going to combine like terms, so I'm going to add 4.1x to each side of the equation. So I got the end is in sight. Feel like we can solve this now. 0.41 equals 5.1x. So divide by 5.1, divide by 5.1. Now, one more time. I got 0.08 equals x. If you got 0.08 equals x, that means we're both good at algebra. And now we can put our chemistry brain back on and we can say, well, we know what x is, so that must be the change, right? And we can plug it in to determine what the equilibrium concentration of each of these substances is. If I plug in 0.08x right here, I get 0.04. Obviously 0 plus x is going to be 0.08 here, and 0.08 here. And those are concentrations now. So it looks like we've got the answer to our question. What is the equilibrium concentration of bromine? Well, here's bromine in this column. Its equilibrium concentration is 0.08 molar. That's it. Done.